Today we are going to take our first step into factoring. However, before we really start to factor, we want to make sure we know how to divide by a monomial. So in order to divide a polynomial by a monomial, we're going to divide each term in the numerator by the term in the denominator. When we've got variables with exponents, we are going to use the quotient rule. So remember, when you are dividing, so if I've got x to the power of a divided by x to the power of b, I am going to subtract those exponents. Now, a lot of times, if we look at example 1, a lot of times you'll hear me say, okay, well, let's use our ovals. So I am going to not do that. I'm going to go ahead and I am going to draw an oval so that I can see exactly what I'm dividing by. So right now I've got 8n squared divided by 4n. So just like when we're dividing with a quotient rule, we're going to do that same thing. Start with our coefficients. So 8 divided by 4 is 2. And n squared divided by n, remember that's like a n to the first power. I'm just going to be n because 2 minus 1 is n to the first power is the same thing as n. So I've done that. Then I can draw my oval for the other side. So we're going to have negative 36n divided by 4n. So negative 36 divided by 4 is negative 9, but n divided by n cancels. So that gives me my answer. Let's do that one more time. Let's look at another example here. We've got negative 14x to the 12th, y to the 5th, plus 7x squared, y squared. So I'm going to divide that all by 7x squared, y squared. So I'm going to draw my oval, and we've got our coefficient, so we've got two variables. But I'm going to start with my coefficient. Negative 14 divided by 7 is going to give me a negative 2. Not 14. X to the 12th divided by x squared. I'm going to subtract those exponents. So 12 minus 2 is going to leave me with 10. And y to the 5th divided by y squared, 5 minus 2 is going to leave me with 3. So I finished that one. I'm going to move on to the other term. So I'm going to draw that oval so that I can see what I'm dividing by. 7 divided by 7 is going to be a positive 1. I'm not going to write 1 because I don't need it. X squared divided by x squared, they cancel. That 7's canceled. Y squared divided by y squared, they cancel. So if everything cancels, then it's 1. If everything is gone, then it's 1. So now that we have gone over how to divide by a monomial, we're going to go straight into factoring. And the first thing it says is, what is factoring? Factoring is separating a polynomial back into a product. Separating a polynomial back into a product. So, for example, let's say I have 4a squared plus 8a. If I separate that back into a product, the factored form is going to be 4a times a plus 2. To prove it to you, I can go in and I can distribute. Well, 4a times a is 4a squared, and 4a times 2 is 8a. So these are the same thing. This is simplest form, this is factor form. And what we're learning today, what we're really focusing on today, is how in the world can I get from this to this? Now, one important thing that we need to know before we move any further is sometimes we're going to have some polynomials that can't be put into a factored form, and when that happens, we call them prime. So just like we've got prime numbers that we can't have anything that multiplies or divides into that number other than 1 in itself, we've got prime polynomials that we cannot factor. So there are multiple methods of factoring, and we're going to kind of work through these throughout this week and next week. But what we're going to start with is factoring by a GCF. A GCF is simply a greatest common factor, and that should be something that you've already learned about, something you've already talked about. You might not have talked about it in factoring, but just in general, the greatest common factor between two numbers. A lot of times you talk about this when you are working with fractions. So go back to elementary school. When you really started talking about fractions, that's probably when you discussed greatest common factor or least common multiple. So moving on, there are several factoring methods. The approach depends on the polynomial. We will start by identifying and factoring out the greatest common factor, or GCF, of the polynomial. So what are the steps for factoring a GCF? Step number 1, identify the GCF of the polynomial. Check the coefficients for a GCF. Now, look at the variables. A variable must be present in all terms to be a GCF. If a variable is present in all terms, take the one with the smallest exponent. Step number 2, we are going to divide each term by the GCF and leave the remaining factors in parentheses. Last step, step number 3, we are going to check our work by distributing. So as you get better at this, you're not going to always have to go back and check your work. But for now, to make sure that we've done it right, we are going to distribute just to make sure our answer is correct. So when we look at number 1, we've got 3x plus 12. So I need to first identify the GCF of the polynomial, and I'm going to start doing that by looking at the coefficients. So my coefficients here are 3 and 12. So I want to know what the biggest number that divides evenly into both of those is. Now, if you can't immediately figure that out, you can kind of go over to the side and say, okay, well, the numbers that are divisible into 3 are 1 and 3. The numbers that go into 12 are 1, 2, 3, 4, 6, and 12. So what is the biggest common factor? What is the greatest common factor? The biggest number that is a factor for both of those? It is 3. So I know the GCF between 3 and 12 is 3. So I'm going to go ahead and write that out. Then I'm going to look at the variables. Do I have an x in each term? No, I do not. So since I do not have an x in both terms, I can't have a variable as my GCF. So once I've got my GCF, I go ahead and I put a parentheses. That's letting me know, all right, it's time to divide. I am going to divide each term by 3. Now, what we did earlier, we divided a binomial by some number. So if you need to come over to the side and you need to draw this out to help you, then by all means do that. So 3x divided by 3, those 3's are going to cancel, and I am left with x. Well, then I'm going to do the same thing with the other term. What is 12 divided by 3? It's going to give me positive 4. And that gives me my answer. That is all I have to do. And if I'm not certain whether or not I'm correct, I can go back and distribute to double check. 3 times x is 3x. 3 times 4 is 12. That is what I got to start with. Therefore, my answer is correct. So let's do another one. We've got 7y minus 7. Well, hopefully you can figure that out right from the get-go. The biggest number that goes into 7 and 7 is 7. Once again, I do not have a variable in both terms. Y is not in both terms, so my only GCF here is 7. That's all it can be. So let's divide this. 7y divided by 7. The 7's are going to eliminate, and I'm going to be left with y. Negative 7 divided by 7 is going to leave me with negative 1. And if we want to go back and double check, 7 times y is 7y. 7 times negative 1 is negative 7, and that is correct. Let's keep moving forward. So, in number 3, we've got 8m and 36n. So looking at 8 and 36, I need to figure out the greatest common factor between those two numbers. Now, this might be one that you can't figure out right away, so go ahead and just write it out. It's okay if you can't figure it out. Sometimes we can't. So the numbers that I can divide 8 by, I can divide it by 1, 2, I can't divide it by 3, but I can divide it by 4, and 8. 36, let's see, 1, 2, 3, 4, 6, 9, 12, 18, and 36. So, what is the biggest common number there? 4. So my GCF here is 4. I do have variables in both terms, but I am looking at the individual variables. So, is there an m in both terms? No. Is there an n in both terms? No. Therefore, they cannot be part of my GCF. So I'm going to put my parenthesis, and now I'm going to divide. 8m divided by 4 is going to leave me with 2m. 36 divided by 4 is going to leave me with 9, and then that n is going to stay, so 9n. Then you could go back, distribute, check it, but this one is correct, I promise. So I'm going to keep moving forward. In this one, the GCF between 5 and 30 is going to be 5. There's not an x in both terms, nor is there a y in both terms, so my GCF is 5. 5x divided by 5 is going to leave me with x. And 30y divided by 5 is going to leave me with 6y. So hopefully you see the more you do this, the easier it's going to get, the more comfortable you're going to get with it. If we look at number 5, what's the difference here? It's just that I got 3 terms. It's still the same process. I'm still going to look for a GCF. I'm going to check those variables, and then I'm going to divide. So between 2, 2, and 4. So if I needed to write this out, I've got 2, which is 1 and 2. I could write 2 again, but I know what it is. And 4. 1, 2, 1, 2, and 4. That greatest common factor there is going to be 2. So my GCF is 2. But now we're going to look at variables because there is an x in all 3 terms. I'm going to take the x with the smallest exponent. So this is x squared, this is x, and this is x. So the biggest thing I can take out is x. Then we're going to look at y. I've got y squared, and y. It's got to be y because that's the smallest exponent. So now that I've got that, I can divide. Starting with that first term, 2 divided by 2, eliminate. X squared divided by x. If I've got 2 x's here and I get rid of 1, I'm left with x. Y divided by y, eliminate. So I'm done with the first one. Negative 2 divided by 2 is going to be negative 1, but I'm just going to put a negative for right now. X divided by x, eliminate. Y squared divided by y leaves me with y. And moving on to that last one. 4 divided by 2 is a positive 2. X divided by x eliminates. Y divided by y eliminates. So I'm finished. And let's just double check that one to be sure. So we're going to have 2xy times x. We're going to have 2x squared y. 2xy times negative y. Well, that's going to be negative 2x, and y times y is y squared. And then 2xy times 2, well, that's going to become 4xy. And if you look That's what we had, so we're right. And we're going to do one more of these together. So we've got 9r to the 8 minus 18r squared s minus 24rs squared. So let's go ahead and figure out those factors. I've got 9, 18, and 24. So my factors for 9 are simply 1, 3, and 9. The only numbers that go into 9. 18, I've got 1, 2, 3, 6, 9, and 18. Well, technically, I could have just stopped at 9 because I know that the number can't get any higher than 9 because that's the greatest factor for 9 itself. So if you just kind of think about this, like here in this example, I should have known that I didn't have to go to 9 because it couldn't be bigger than 8. So don't sit there and write out all of this stuff if you know it can't go any further. So for 24, we've got 1, 2, 3, 4, 6, 8, 12. Well, I know it can't go past that, so I'm going to stop. So the greatest common factor, well, 24 is not divisible by 9, so it can't be 9. But it can be 3. So my GCF is 3. And now we're going to look at those variables. So there is an r in all three terms. Got r to the 8th, r squared, and r. I have to use r because it's got the smallest exponent. Then we're going to look at s. However, there's not an s in all three terms. This one's got it, this one's got it, but this one doesn't. So it cannot be my GCF. Now we can divide. 9 divided by 3 is 3. R to the 8th divided by R is going to be R to the 7th. Negative 18 divided by 3 is going to give me negative 6. R squared divided by R is going to be R. And I'm not dividing S by anything, so S isn't going to change. Negative 24 divided by 3 is going to leave me with the negative 8. R divided by R cancels, and that S squared is going to stay the same. So that is all there is to factoring by GCF. Find the GCF, divide it, and get your product, and you are finished. So, as always, please let me know if you've got any questions. Go back and review this video if you are confused. I will post some extra help videos within the Delta Math assignment, so please reference those if you need them. And I hope you have a marvelous day.